Okay, so I promised you another test. So the next test is the limit comparison test. And I'll be honest, I always forget this test. And I always think when every time I see it, I'm like, wow, I really should remember this test. Okay, because honestly, it would make my life a lot easier if I just always remembered this test. So let's hope that this time I do. Okay? So let's suppose, let's let the sum in A sub n and B sub n be series. Okay? Then, if, oh, they should also be, we're dealing with positive series right now. Okay? If the limit as n goes to infinity of A sub n over B sub n equals some c that's bigger than 0, but c should also be finite. If it was infinite, then B sub n over A sub n would be 0. So there's some symmetry there. Okay? You don't have to know which one, you don't have to choose which one's on top. Okay? Either one should work. Then either they both converge or they both diverge. Okay, so let's take a look at that last one we were just looking at. Okay, we were looking at the sum. N goes from 2 to infinity, n cubed over n to the fourth minus 1. Okay, so now one of the things is that we notice is that n cubed over n to the fourth minus 1, that kind of looks like 1 over n. And we know that the sum of 1 over n is divergent. Okay? Now, let's compare. Let's do a limit comparison of this series with this series. So we're going to take the limit as n goes to infinity, n cubed over n to the fourth minus 1 divided by 1 over n. That's the limit. N goes to infinity, n to the fourth over n to the fourth minus 1, and that just equals 1. So this goes towards some c that is finite but not in 0. Okay, so this series diverges. We already knew that from the integral test, but it's good to see it with another test as well. Okay. Okay, let's take a look at another one. Okay, let's take a look at the sum. N goes from 1 to infinity, n minus 1 over n 4 to the n. Let me write that a little nicer. Okay. All right. So this thing, what we kind of see okay, is we know that 1 over 4 to the n, we're gonna do a limit comparison with 1 over 4 to the n. Now this is a geometric series. So that it's a geometric series with the radius less than 1. So it definitely converges. Okay, so we're going to compare this series with this series. Okay, the 4 to the n's are actually going to cancel. Again, that's 1. Again, that is a finite non-zero C. So this one's going to be convergence. We don't necessarily know what it converges to, okay? And we're not asking that. We're just asking, is it convergent, okay? I mean, once you know that a series converges, there's lots of things you can do to find the sum that aren't really analytical in nature. You could just, you know, plug this into an Excel spreadsheet, sum up a bunch of them, and be like, yeah, that works good enough. Okay, it's not quite, but it gives you a sense of it, and a lot of times it will work. Okay, all right. See you in the next video.